Hello, so I wanted to do a video today on completing the square. This is quite an advanced topic and it does require you to have an understanding of kind of some other areas of maths before you jump into this. So if you are not completely comfortable with expanding double brackets, operations with fractions and there's a basic understanding of quadratic graphs, I suggest you go and have a look at some of those areas before you do this. What I mean by expanding double brackets is questions that look a little bit like this. For example, x plus 4 squared. Remember that squared means everything in the bracket times itself. So x plus 4 multiplied by x plus 4, and then you'd expand and simplify those brackets. Operations with fractions, things like multiplying fractions, adding fractions, subtracting fractions, and quadratic graphs. I've done a quick sketch of a quadratic graph over on the left here. Completing the square, the topic that I'll go through some examples of in a second, has a couple of uses. You can use it to solve quadratic equations. You will have already done some solving quadratic equations by factorizing and by using the quadratic formula. This is another way of solving them. It also allows you, on a quadratic graph, to find what we call the turning point of the graph. So the coordinates of the lowest point of the graph, or if you've got a quadratic graph that looks like that, that's the turning point of that one. So that will give you the coordinates of that as well. I have 4 examples to go through, and we're going to start with this one here. Now this is not a quadratic equation, it is just a quadratic expression because it doesn't equal anything. So the first thing you're going to do with these questions is I'm just going to write out x squared plus 24x plus 5. Okay, now I always suggest you just double check that it's written in descending powers of x. What I mean by that is your x squared term comes first, and then your x term, and then just your number bit on the end. So to start with, we are only interested in these first 2 terms here. What you're going to do is, in a bracket, the x squared becomes an x, and we half the coefficient, the number before the x. So instead of plus 24, I'm going to write 12. Now, we're going to square that bracket. My final answer still needs to give me this whole expression here. If I were to expand that bracket, remember x plus 12 multiplied by x plus 12, if I use the method, this would give me x squared plus 12x plus 12x plus 144. So if I've simplified that, that would give me x squared plus 24x plus 144. Now you'll notice this bit here and this bit here are the same. What we didn't want is this plus 144 bit, which came from positive 12 multiplied by positive 12. So what we then need to do is we need to take away 12 squared, and this bit here will always be the same as that bit there, but we're taking it away. And then this plus 5 bit, we need to put that on the end as well. So what we're now going to do is just tidy the bit after the bracket up. So it's still going to be x plus 12 squared. This becomes minus 144, and then we need to put that plus 5 bit on the end as well. So this becomes x plus 12 squared. Minus 144 plus 5 becomes negative 139. That's it. We have now completed the square. That's the easiest example. I'm now going to show you what that might look like and how you might use that. So this here is the equation of a quadratic graph. Y equals x squared plus 16x plus 2. We are asked in this equation to find the turning point of that graph. Remember that turning point, this isn't accurately drawn, but that turning point would be this bit here. In this case, the lowest point of the graph. So the way we're going to do that is I'm just going to write out the equation again. Y equals x squared plus 16x plus 2. We're going to complete the square for this bit here. So remember, in my bracket, we're going to write x, half the coefficient, include the sign, but half the coefficient of the x. So that becomes plus 8 squared. Now, if I expanded this bit here, x plus 8, I would get x squared plus 8x plus 64, or x squared plus 16x plus 64 if I expanded that. I didn't want this bit here, so I want to take away this bit squared, and then I can put that plus 2 on the end, and that was y equals. So if I tidy this bit up, I get x plus 8 all squared, take away 64, 8 squared is 64, and then add 2. And then I'm going to just finish that up by going x plus 8 squared, negative 64 plus 2 gives you negative 62. Now, we can use this to find the turning point of the graph, so the coordinate of the lowest point of this graph. The way you do that is you are interested in this value here inside the bracket next to the x, and you're interested in this value here. My coordinate, the y coordinate, is this bit here, negative 62. The x coordinate is the inverse of what is in the bracket after the x. So plus 8, instead of plus 8, this is going to be negative 8. So that tells me if I were to draw this graph accurately, the minimum point of that graph would be negative 8, negative 62. Okay, example 3. What we're going to do here is, it looks similar, but you'll see why it's a little bit more complicated in a second. This is just an expression, just being asked to complete the square here. We are not being asked to find the turning point of the graph. The reason this bit is a bit more tricky is because when we come to half this bit, you'll see that 11 cannot be halved and give an integer a whole number. So I suggest for a second leaving it as a fraction. Now, when I expanded this bracket, I would get x minus 11 over 2, x minus 11 over 2. This would be x squared. This would be 11 over 2x, sorry, negative 11 over 2x, so with this. And then this bit here would be positive. 11 squared is 121, and 2 squared would be 4. So what we are then going to do is we're going to take away this 11 over 2 squared. Remember, when you multiply two negatives together, that gives you a positive, which is why I'm taking away. I then want to put that plus 13 bit on the end. So I'm now going to do this squared. Now, 11 over 2 times 11 over 2. Remember what I did here. 11 times 11 is 121. 2 times 2 is 4. So we're actually taking away 121 over 4. And then we're adding 13. Now, to tidy this bit up at the end, this bit here, remember when you are adding or subtracting with fractions, the denominators must be the same. So to tidy this bit up, I'm gonna write negative 120 over 4 plus any whole number can be written as a fraction by writing it over 1, because remember, a fraction is a division that we have not yet completed. So this means 13 divided by 1, which would give me 13. To add or subtract fractions, the denominator must be the same. So if I multiplied 1 by 4 to get 4, I also need to multiply 13 by 4 to get 52. Okay, so now I'm doing negative 121, and I'm adding to that 52. That gives me negative 69. So my final answer for this one becomes x minus 11 over 2 squared, and then I'm taking away 69 quarters, so take away 69 over 4. That's it, that's the answer for that one. Okay, last example. Let's go for, this is similar to question 2, apart from it's a bit nasty because it's got an odd number in front of the x. So I'm going to write y equals x squared plus 13x minus 19. Remember, we need to half that 13. I would leave it as a fraction rather than converting it to a decimal. So y equals that. We then want to subtract this bit squared. And then we can put that don't forget that minus 19 on the end. So I'm going to end up with y equals x plus 13 over 2 squared. I'm just going to take this fraction over here a second and square it, which means multiply it by itself. 13 squared is 169, 2 times 2 is 4. So we're going to take away 169 over 4, and then we're going to take away 19. Remember this bit here, we're trying to do negative 169 over 4, and we're taking away 19 over 1. Again, to add and subtract fractions, the denominator must be the same. So I need to make that one so it's written over 4. So using an equivalent fraction, 1 times 4 gives me 4. 19 times 4 gives you 76. So negative 169, take away 76 is going to give you negative 245 over 4. So now what I can do is I can write x plus 13 over 2 all squared, negative 245 over 4. Okay, now this is one of the questions where it asks us to find the turning point. So as soon as you've done this, you can now say that the turning point, remember that sign changes, so it's negative 13 and negative 245 over 4. That's it. That would be where our graph, the turning point of our graph. If you were to plot that graph accurately, that would be the lowest point of that graph. These questions do get more tricky, but I won't go into the more tricky ones today. I have another question generator that I've made. Remember, when you open it, you have to click Enable Content in the yellow ribbon at the top. I will put a link to this file in the description of the video so you can download it and get some practice. As always, you can generate new questions. They're currently set to increasing difficulty, but if you want to try a certain type of question, you can try all type 2. Once you've done all 4 and you've got the hang of them, it would be a good idea to practice a mixture where I don't tell you what kind of difficulty it is, and you have to use everything that we've covered to try and answer those. That's it. I hope that's been useful. Thank you very much as always for watching. Bye bye.